All right, so we have acid-base catalysis. And so first off, let's talk about catalysis. All these are catalysis, right? Or catalysts working, right? I.e., catalysis is how a catalyst does its thing, right? And so if we just define catalyst, that's going to go under all because that's what they all share. And so what does a catalyst do? Well, it lowers the energy or stabilizes your transition state or intermediate, right? So if you remember your energy diagrams, you have your reactants, then an E sub A, right? Activation energy that we have to overcome, and then we have products, right? And so remember, a catalyst only affects the kinetics, which is the E sub A, right? The activation energy. Meaning the stuff in the E sub A is going to be given an alternate path, which it does not have to go over the entire mountain, right? Kind of easy way to envision this in your head is what a catalyst does. Instead of having to go over, the Himalayas, it gives you a pathway around them, right? So yeah, you might have to take more steps, like binding the enzyme, etc. But each one is much faster and easier to do. Does that make sense? Everybody comfortable with that so far? Fantastic. Okay, and then we just gotta go down, and really you just need to know what these things mean. Acid base, covalent, metal ion, right? And so acid base, well, what does an acid base reaction do? It's gonna involve the transfer of a proton, right? And so a proton is transferred between enzyme and substrate. Okay? Literally what an acid-base reaction is, right? Acid-base, protons transfer between substrate and enzyme. Fair enough, right? Anybody have any issues there? Okay. Covalent catalyst, or covalent catalysis. A covalent bond forms between the enzyme and substrate. Well, that makes a lot of sense, that match, right? If we're forming a covalent bond, then we're probably forming covalent catalysis, right? Use of a nucleophilic functional group. What is the most common? Okay, so we had groups on these, right? It would have been some sort of substrate, and it seems unlikely that this would be like an addition or elimination reactions all the time, right? Because most of those, addition forms new bonds. But for the most, it doesn't seem very likely you'd always have a double bond, right? So what tends to be the, what would you normally expect to be forming these bonds to things? Something like a substitution reaction, right? Specifically like an SN. And so what would you expect to be involved in this? Some form of nucleophile, right? Like a nucleophilic. So uses a nucleophilic functional group. That makes a lot of sense once you look back at your organic chemistry, right? What's the most common way to go ahead and substitute in a single bond to attach something new? Yeah, nucleophilic attack, right? Like an SN. Yeah. So that makes a lot of sense, doesn't it? Does anybody have any issues with that? Okay. Also, this tells you acid base. It doesn't make any sense that this would be a nucleophile and be attacking like positive carbons, right? Remember, nucleophile is a much broader definition than acid base, right? Like, yes, many bases are nucleophiles, right? But nucleophile would indicate that you're going to make some sort of covalent bond, right? And metal ion obviously doesn't make any sense. You're anything to do with covalent bonds, right? Some sort of metal ion involved, right? Okay, so the next one, metal ion, and you only have two options. Oops, I skipped some stuff. Sorry about that. Let's go back to the acid base real quick. Okay, so may use amino acids such as aspartate or lysine for protonation or proton abstraction. First off, you only need to know what those look like. because it says protonation or proton abstraction, right? Moving protons, that's an acid-base reaction, right? So you don't even need to know more, do you? Proton transfer, acid-base. There you go. Done, right? Okay. For covalent two-part catalytic process, for example, the chymotrypsin mechanism. Well, all of a sudden, if you have a covalent bond being formed, then to remove your substrate, what do you need to do? You need to break a covalent bond, don't you? And whenever we do a mechanism, we always have separate steps for whenever we break and form covalent bonds, right? So the fact of the matter is, if you make a covalent bond to attach this thing and do this reaction, you're going to have to break it, aren't you? And so all the time, always, a covalent catalyst is going to have two steps, one making covalent bond, one breaking it, right? Automatically, there is no other option, right? Because obviously the enzyme can't be consumed, can it? It wouldn't be a catalyst if it's consumed, right? Is that clear for everybody? Okay. You understand what I'm saying about it can't be consumed? If it made a covalent bond and then never broke it, that would mean the catalyst would be consumed, right? Because what is a catalyst? Well, you start the reaction with it and you end the reaction with the same thing, right? So you always have to regenerate your catalyst. Okay. Metal ion. Okay, so the catalyst may participate in oxidation reduction reactions by changes in oxidation state. So changes in oxidation state in acid base are going to involve a proton transfer, right? It's never going to just be as simple as changes its oxidation state. Covalent, that's not even going to change the oxidation states, is it? No, I mean, it will, but you'd have to add like a hydrogen to it or something, right? It's not, it doesn't just change your oxidation state. There's a lot more stuff going on there, right? Metal ions, what do you remember about metal ions like iron? They exist, especially ones in the middle. They can exist in multiple different oxidation states, right? There's something that easily loses, and if they're available, gains electrons. So something you can pull the electrons off easily, right? And so metal ions are very good at participating in events where you would oxidize or reduce them, right? In fact, you may remember from general chemistry, when we did the oxidation reduction chapters, all the reactions you did in lab, they all involved metals, didn't they? Why is that? Because they're easy. We don't do it with the other stuff because it's hard, right? It would take a lot of time and effort, and we would get all sorts of byproducts, and yeah, it'd actually be very dangerous. So, yeah. Yeah. Okay. By the way, does like a proton going onto a base, does that change its oxidation state? Does it? Okay, so oxygen is -1 when it's the O minus, right? When it has a hydrogen on it, what is it? Negative still, right? Hydrogen doesn't take the electron, does it? No. So typically acid-base reactions don't change their oxidation states of the acid and base, okay? Now you can use an acid on a metal to change its oxidation state because hydrogen will take the electrons from the metal, right? But that's not an acid-base reaction anymore, is it? That'd be actually a metal ion specifically being made. So a zinc 2+ cofactor may properly orient the substrate in the active site through ionic interactions. Hopefully this one almost goes unexplained, right? Zinc 2+ is a metal, specifically ion, right? So that has to be a metal ion. I know, right? So complex. That's like a General Chemistry 1 first week problem, isn't it? May take part in interactions involving Fe2+. Oh my, this one's... So that's again a metal ion, isn't it? And so this is probably a metal ion, right? Catalyst. Okay. Again, this is the definition of a catalyst, right? Catalyst retains its original form after reaction occurs. Definition of a catalyst, you have to begin and end with the catalyst. The catalyst always has to be regenerated, right? Okay. If it doesn't regenerate at the end, it's not a catalyst, is it? It's a substrate. Okay? Okay. Does anybody have any problems with any of those? Did I confuse anybody? No? Okay. It's not that bad, right? You just need to take it step by step. It's one of those things that really just need, first couple weeks of organic chemistry, probably would have done it. And you can work your way through it. Okay. Anybody have any other questions at all on this or something else?